Hello friends, I welcome you in lecture number 14 on basic probability. In this lecture we will discuss one more problem on the probability theory. This question was asked in GTU Summer 2022 exam for 7 marks, and in this question we are going to use definition of conditional probability. Suppose event A has occurred before event B, and suppose event B depends on event A, then probability of event B given that A has occurred is given by probability of intersection of A and B divided by probability of A. Similarly, we can write this probability also. Suppose event B has occurred first and then event A occurs which depends on event B, then this is given by probability of A intersection B divided by probability of B. So we have two expressions for probability of A intersection B. If I use this one, I will write probability of A intersection B equal to probability of A into probability of B given A. And if I use this one, I can write this as probability of B times probability of A given B. So whatever is required, we will use that formula. This formula is sometimes this is known as multiplication rule for probability also. So probability of intersection of A and B, that is probability of occurrence of A and B at the same time, can be given by probability of A times probability of B given A, or probability of B times probability of A given B. Okay, fine. So first we read this question, we write down whatever is given, and we understand that what we are asked to find out. It is given that 70% of the light aircraft that disappear while in flight in a certain country are subsequently discovered. So here the question is related to the aircrafts while they are in flight, and they are interested in the aircrafts that are discovered. So out of total number of aircrafts, it is given that 70% of the light aircraft are subsequently discovered. Of the aircraft that are discovered, 60% have an emergency locator, whereas 90% of the aircraft not discovered do not have such a locator. So here another event we can consider as aircraft having an emergency locator. One event is aircraft which are being discovered. Another event we can consider as aircraft having an emergency locator. Now what is given of the aircraft that are discovered? That is, if the event that aircraft is discovered is occurred first, then out of those aircrafts which are discovered, 60% are having emergency locator. Similarly, it is given that suppose aircrafts, we consider the event that aircrafts are not being discovered, then out of those not discovered aircrafts, 90% do not have such a locator. Suppose a light aircraft has disappeared. Now we have to decide these two probabilities. If it has an emergency locator, that is, suppose aircraft has an emergency locator, what is the probability that it will not be discovered? Another probability we have to decide is, if it does not have an emergency locator, what is the probability that it will be discovered? So mainly here there are two events. Suppose event D denote the event that aircraft is discovered, and we denote the event E as aircraft having an emergency locator. Suppose E denote the event that aircraft has an emergency locator, and D denote the event that aircraft is discovered. Now what is given? 70% of the light aircraft are discovered. That is, probability that aircraft is being discovered is 70%, that is 0.7. And suppose we are interested in the probability that aircraft is not discovered, then that event will be complementary event of this D, and probability of D dash is 1 minus probability of D. Probability of D is 0.7, so this is 0.3. Probability of aircraft being discovered is 0.7. Probability of aircraft not being discovered is 0.3. And here it is given that of the aircraft that are discovered, that is, event D occur first. Suppose aircraft is being discovered. Of the aircraft that are discovered, 60% have an emergency locator. That is, if given event is aircraft is discovered, then probability that aircraft has an emergency locator is probability of E given D, and it is 60%, that is 0.6. Similarly, it is given that 90% of the aircraft not discovered do not have such a locator. That is, it is given that aircraft is not being discovered, that is D dash occur, and aircraft do not have such a locator. That is, out of those aircrafts, that is, if aircraft is not discovered is occurred first, and probability that aircraft does not have an emergency locator is given as 90%, that is 0.9. This 0.9 is the probability that aircraft does not have an emergency locator given that aircraft is not being discovered. Okay, you can understand from this, 90% of the aircraft not discovered do not have such a locator. That is, 90% aircraft do not have an emergency locator, that is E dash, of the aircraft not discovered, that is D dash. So D dash occur first, and probability of E dash given D dash is given as 0.9, and this is given information. Now using this information, we are asked to find out these two probabilities. If it has an emergency locator, that is, event E occurs first. Suppose an aircraft has an emergency locator, what is the probability that it will not be discovered? That is, we have to decide probability of D dash given E. Similarly, here, if it does not have an emergency locator, that means E dash occurs. What is the probability that it will be discovered? That is, probability of D given E dash. So we have to decide probability of D dash given E and probability of D given E dash. We are asked to find out probability of D dash given E and probability of D given E dash. So for this, suppose I use the definition of conditional probability. Probability of D dash given E, this is equal to probability of D dash intersection E divided by probability of E, and for that I will require probability of E, that is, aircraft has an emergency locator, that is not given, so we have to decide that probability also. And probability of D dash given E can be written as, using multiplication rule, probability of D dash into probability of E given D dash. So let me see, this is given or not. Probability of E given D dash, that is not given, but probability of E dash given D dash is given. So we can find out probability of E given D dash using this complementary event. We can write probability of E given D dash and as 1 minus probability of E dash given D dash, and this is given, so it is going to be 0.1. So this we can obtain from that probability of E dash given D dash. This is also we have obtained, and we have to decide probability of E. Now to decide probability of E, we can write E as intersection of two mutually disjoint event. Suppose I consider D intersection E. I can write E as D intersection E union D dash intersection E. Okay, if you simplify this, you will obtain this event E. So this E is written as union of two mutually disjoint events, and therefore by addition rule of probability, this we can write as probability of D intersection E plus probability of D dash intersection E, and this is using definition of that multiplication rule. This we can write as probability of D times probability of E given D plus probability of D dash times probability of E given D dash. Now we have obtained this probability of E given D, that is given 0.6. Probability of E given D dash is 0.1. So we are having those probabilities. Probability of D is also we are having, D dash is also we are having. So using this we can obtain probability of E. This formula is also known as total probability rule, and using this total probability rule we will be able to decide probability of E, and once we obtain probability of E, we can obtain this probability of D dash given E. Similarly, for probability of D given E dash, we have to go in the similar manner. So that I have written all these things systematically here. First we write down that notations for these events. Suppose the aircraft is discovered is denoted by capital D, and E denote the event that the aircraft has an emergency locator. Given that 70% of the aircraft are being discovered, that is probability of aircraft being discovered is 0.7. Similarly, the probability of aircraft not being discovered is given by probability of D dash. D is the event that aircraft is discovered. Its complementary event is aircraft is not discovered, that is probability of D dash is equal to 1 minus probability of D. Probability of D is 0.7, so this comes out to be 0.3. It is also given that out of those aircrafts which are being discovered, 60% have an emergency locator. So that we can write in the language of probability as probability of E given D equal to 0.6. Similarly, it is also given that out of 90%, out of aircrafts not being discovered, 90% aircraft does not have an emergency locator, that is probability of E dash given D dash is 0.9. And as I discussed, using probability rule, the probability of aircraft having emergency locator, that is probability of E, is given by probability of D times probability of E given D plus probability of D dash times probability of E given D dash. Probability of E is 0.7. Probability of E given D is given as 0.6. Probability of D dash is 0.3 that we have obtained from probability of D, and probability of E given D dash can be obtained from probability of E dash given D dash using the definition of complementary event. These two events, E given D dash and E dash given D dash, these two are complementary events. Therefore, probability of this event equal to 1 minus probability of its complementary event, and we are given that probability of E dash given D dash is 0.9. So we have 1 minus 0.9, that is 0.1. So this is 0.1, and this is going to be 0.42, this is 0.03, and therefore the probability of aircraft having emergency locator is 0.45. Now in the first part we have to find that if it has an emergency locator, that is if event E is given, what is the probability that it will not be discovered, that is probability of D dash given E. So that we can obtain now probability that aircraft will not be discovered provided or given that it has an emergency locator, that is probability of D dash given E. Using definition of conditional probability, it can be written as probability of D dash intersection E divided by probability of E. This we can write as probability of D dash times probability of E given D dash divided by probability of E. And we have obtained all these things. Probability of D dash is 0.3, probability of E is 0.45, probability of E given D dash is 0.1. So using all these values, we find that probability of D dash given E is 0.0667. That is probability that aircraft will not be discovered provided that it has an emergency locator is 0.0667. In the second part, we are asked to find that probability that an aircraft will be discovered, that is probability of D, provided that it does not have an emergency locator. Event E is the event that aircraft has emergency locator. Therefore, event that aircraft has no emergency locator is E dash. So we are asked to find out probability of D given E dash by the definition of conditional probability. It is probability of D intersection E dash divided by probability of E dash. This we can write using multiplication rule. Probability of D times probability of E dash given D, and the probability of E dash can be written as 1 minus probability of E, complementary events. Same thing here, probability of E dash given D is equal to 1 minus probability of complementary event of this, which is 1 minus probability of E given D. And probability of E given D is given as 0.6, probability of D is also given 0.7. We have obtained probability of E as 0.45 in first part, so that we substitute here 1 minus 0.45, and using all these calculations we are able to find out probability that aircraft will be discovered given that it does not have an emergency locator is 0.5091. So this is very nice question related to the conditional probability and multiplication rule for probability, and you can easily find out the required probabilities using this type of logics. So first you have to define your events. Whatever is given you have to write in terms of probability, and using definitions of complementary events using total probability rule, you have to decide probability of E, which is not given. Here we are not given probability of E, but what is given? We are given probability of E given D, probability of E dash given D dash. So that is not given directly. We are given probability of E given D. This is also given. This we can find using probability of D, and this is also not given, that we have decided using this probability. Okay, this we have obtained using this complementary event rule. So this is also not given. So using all this information, first we have to decide what is probability of E, because we require probability of E to obtain this probability. In the denominator we require probability of E. So first we have to calculate probability of E using total probability rule, and then using definition of conditional probability we are able to decide required probabilities. So this is all about this session. If you have any doubts, you can ask in the comment section. Thanks for watching.